Hello, my name is Morgan. This is the 6th entry in a series of development logs for an action RPG game in very early development. The log is released roughly each week. This episode is about a very important feature that now is implemented in the engine. That is the feature of level streaming, which means that it is possible to have a very big level on disk, though only parts of it are loaded at once, meaning that there should be no loading times in the game, only a seamlessly big world to explore. The test level consists of 100 ground squares, each of which are about 20 by 20 meters in size, giving a world that is about 200 meters wide, not very huge, but sufficient to show the concept. Each square also has its own rough light map to show some light effects. The level itself is described in one file, which reference all other more heavy data. While the player moves around, the file is queried to see if any models are within a viewable distance, so they can be loaded. Also loaded are some submodels, since all models have a parent and child relationship. In the same time, models that are in non-viewable distance are unloaded. The general concept of streaming is quite straightforward, though it is made much more complicated by the fact that game data is very diverse, because a game consists of several data types. The main ones are meshes, the vertices that build objects in the game, textures, ordinary pixel data, images to put everywhere. Also audio data is used. So to do this, first the data has to be loaded from disk to memory. This has to be done in its own thread, not to stall the game. And this thread sees to it that the loaded data is always available for all other subsystems to load. And the next subsystem is the graphics. So there, when you have the data, the meshes and the textures, those have to be uploaded to the graphics card without calling any stalls. And this is problematic because OpenGL calls are not asynchronous, meaning that they stall the whole program until the data is loaded. And the biggest villain here in this case are very big light map textures. And if I would use ordinary texture uploads, those uploads would stall the whole program for quite a while, maybe a second or so. Though this was solved with something called pixel buffers, pixel buffer objects I would say, which gives you a chunk of memory on the GPU to upload to without stalling the program. And when the uploading is done, the data can be put into a texture for further use. I have not loaded any audio data to this level yet, though since the engine uses OpenAL for audio, and most of those calls are actually asynchronous, so it should be more easy and straightforward to implement the audio for this streamed level. And hopefully we will see more of that in further episodes. This is all for this episode. Feel free to chime in on development, questions, suggestions and tips. All feedback is very much welcome. Like or subscribe if you want to. Thank you for watching and see you next time.